Hi, my name is Akshay, and I'm from the Tiger Paw Academy. Okay, and today I'm here to teach you a lesson about reciprocal trigonometric ratios. And you're going to be really fascinated by all the amazing facts you're going to learn today. Well, let's get started, okay? Okay, so reciprocal trigonometric ratios have many uses in today's life. Remember, before we start the lesson, remember what SOHCAHTOA is: sine, cosine, and tangent. To calculate sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; and tangent, opposite over adjacent. Now, what is reciprocal? This is what we need to know today. Two expressions that have a product of 1. As you can see in the examples, 4 and 1 over 4, 5 and 1 over 5, 3 and 1 over 3, x and 1 over x. Cosecant ratios. Reciprocal of the tangent ratio. Okay? Cosecant ratio. Reciprocal of the sine. Secant ratio. Reciprocal of the cosine. Now let's go on to example 1. Consider a right triangle with side length 6 units, 8 units, and 10 units, like the one you see to the right, measured A, B, C. Determine the 6 trigonometric ratios for angle A. Then, determine the 6 trigonometric ratios for angle B. Now for angle B, I would like you to do that by yourself and get help from teachers or friends. Okay, so first we're going to be calculating angle A. Solution. So remember, to calculate sine A, it's equal to opposite over hypotenuse, which is 6 over 10 when looking at the right triangle below, which simplified 3 over 5. Cos A, same thing, adjacent over hypotenuse, 8 over 10, simplified 4 over 5. Tangent A, opposite over adjacent, and that's 6 over 8, simplified 3 over 4. Now remember, cosecant is the opposite or reciprocal of sine A, which is hypotenuse over opposite, 10 over 6, which is equal to 5 over 3. Secant A, hypotenuse over adjacent, 10 over 8 equals 5 over 4. Cotangent, remember, and adjacent over opposite, 8 over 6, which is equal to 4 over 3. Remember, these are all reciprocals of sine, cosine, and tangent. Okay, so that's the solution to question number 1. Now, let's go on to example 2. Each angle is in the first quadrant. Determine the measure of each angle to the nearest degree. Cosecant A is equal to 9, B. Secant B is equal to 20 over 3, and C. Cotangent C is equal to 7 over 16. Alright, let's go to the solution. A. Cosecant A is equal to 9. Remember, sine A is equal to 1 over 9 due to reciprocal. Now to get angle A is equal to 6 degrees, you do sine inverse of 1 over 9. That is how you get the degree. Let's go to B. Secant B is equal to 20 over 3. Cos B is equal to 3 over 20, which is the reciprocal. Angle B is equal to 81 degrees. Remember, cos inverse of 3 over 20 gives you 81 degrees. All these inverse for sine inverse, cos inverse, and tan inverse give you the degree for what you want to find out. Cotangent C is equal to 7 over 16. Tan C is equal to 16 over 7 due to reciprocal. And angle C is equal to 66 degrees if you put tan inverse of 16 over 7 on your calculator. Now let's go to example number 3. Okay, determine two primary angles between 0 degrees and 360 degrees that have a cosecant of 5. Okay, so let's look over here. On the right hand side, I have a grid with a circle, right, that measures all, sine, tangent, and C. That's what the letters stand for. Okay, I tried to draw a circle, didn't turn out that well. So sine inverse is 1 over 5, which is the reciprocal. So sine inverse of 1 over 5 is equal to 12 degrees. So now what we have to do is 180 degrees minus 12 degrees. Why do we do this? Because remember, A is the quadrant where everything is positive. Sine is a quadrant where only sine is positive. So you do 180 minus 12 degrees, which is equal to 168 degrees. And remember, in order to double check your work, sine 12 is equal to 0.207, and you put sine 168 on your calculator, and that's also equal to 0.207. So therefore, you have the correct answer, and therefore the two angles are 12 degrees and 168 degrees.